Hello, welcome to session 2 of the Lawson Fuse's Fuse Masterclass. Last time we talked about what a fuse is and the basic science behind it. Let's talk about what an HRC fuse does and what its function is. In this case, the fuse will be GG rated, a general purpose fuse link. There are 3 requirements that must be fulfilled for each HRC fuse design. Number 1, it must safely interrupt very high current short circuit faults. Number 2, it must also safely interrupt very low current overloads from just over the normal rating. Number 3, it must ensure that the fuse link has a low power dissipation. You may know power dissipation as Watt's loss. The low power dissipation is to reduce wasted energy and makes the fuse link less dependent on ambient temperatures. All 3 requirements are tightly controlled within the fuse standards. Okay, so we've talked about the theory and what the fuses have to do. Let's have a look at the construction of a fuse link. We'll talk initially about fuse links with cylindrical barrels. From the image shown, you can see the general construction. A fuse link, body or barrel, normally ceramic. 2 inner caps to connect the elements to. 2 outer caps to connect the tags, if required. 1 or more elements, and these are the parts that melt. 2 tags to enable connection to your interface or holder. And lastly, the filler or silica sand. If you've ever broken open an HRC fuse or seen inside one, you will see they are always filled with sand. All HRC fuse links contain a filler or sand. This is not common sand from the local beach. This is high purity silica sand, a purity of around 99.5%. We'll talk more in detail about the filler, as this is one of the most important parts and also happens to be one of the most common questions we get. Because the sand filler is one of the most important parts of the fuse link, the controls for the sand are quite complex. The sand follows a particular treatment process within the factory. Number 1, it is dehumidified to remove any dampness and generally kept warm throughout the manufacturing process. Number 2, high power magnets are used to remove any ferrous materials. Number 3, the sand is put through a sieving machine that sorts particle sizes to remove any large or small particle sizes. This is an automated process. Number 4, a second check for ferrous materials is done to ensure the magnets have done their job and that there are absolutely no ferrous materials present. The sieving is important as the particle size is extremely relevant. The sand needs to be packed into the fuse in the same way each time. If the sand particles are too small, the sand packing will be too tight and may cause extra pressure to the ceramic barrel when the fuse link operates. Remember that whenever it happens, the barrel should not break. If the sand particle size is too large, it will not effectively restrain the arc when a fault is seen. The sand is principally to extinguish the electric arc formed when the element melts. It also cools the element under normal loads and enables it to carry a larger current. When the element melts and interrupts the fault current, an electric arc forms across the break. This high temperature generated by the arc melts the sand and produces a material called fulgurite. This assists the arc extinction and forms an insulating barrier in the barrel. When I say high temperature, I'm talking more than 1800 degrees Celsius. You do see fulgurite forming in nature when lightning strikes a sandy beach and melts the sand, particularly in Australia. Have a look at the image to see fulgurite formation. You can see the melted sand mixed in with the atomized copper particles from the element. When a fuse link operates, there are 4 distinct stages for short circuit protection. Stage 1, melting of the copper elements. This is called the pre-arcing. Stage 2, vaporization of the element. This is when the internal arcing takes place. Stage 3, the fusion of copper vapor and filling material. This is when the fulgurite is formed. And lastly, stage 4, the arc extinction takes place. So at this point, the input is isolated from the output side of the fuse. The elements have burned away to remove the arcing path, and a further protection is given by the insulating properties of the formed fulgurite. Okay, so we've now covered the basic theory, the construction of the fuse link, and talked about the importance of the sand filler. I hope you found it interesting. Next time we will talk about other components within the fuse link. Don't forget to follow, share and comment. Thank you.